Gaussian surface and Gauss's theorem. Let us learn what is Gaussian surface. Gaussian surface is an imaginary closed surface around a charge. It can be a spherical surface, a cubical surface, a cylindrical surface, or a surface of any shape. It should be a closed surface. Let us learn Gauss's theorem. Gauss's theorem states that the total flux through any closed surface is equal to 1 by epsilon 0 times total charge enclosed by the surface. Let us write the Gauss's theorem in the form of an equation. That is, total electric flux through the closed surface is equal to 1 by epsilon 0 times total or net charge. Total electric flux can be represented by phi. Phi is equal to 1 by epsilon 0 into Q. Q is the total charge enclosed by the surface. You know, flux through a small area ds is given by the equation d phi is equal to E dot ds. So the total flux through the total area is given by phi is equal to closed integral E dot ds. According to Gauss's theorem, total flux phi is equal to 1 by epsilon 0 times Q. Instead of phi, we can write closed integral E dot ds is equal to 1 by epsilon 0 times Q. Proof of the Gauss's theorem. Consider charge Q is placed at O. Let P be a point at a distance r from the charge. The electric field intensity at P is E, that is acting radially outward. That's given by the equation E is equal to 1 by 4 pi epsilon 0 Q by R square. Consider a spherical surface with O as center and R as radius. And this is the Gaussian surface we consider it. P is normal to the surface. When we consider at every point on the surface is normal to the surface. Consider a small area ds around P. Electric flux through that small area is given by E dot ds is equal to E ds cos theta. Here theta is 0. Therefore, equation can be written as E ds. The value of E can be substituted here. 1 by 4 pi epsilon 0 Q by R square into ds. Flux through the Gaussian surface is calculated by considering this type of small areas and added up. Instead of that, we can write closed integral E dot ds is equal to closed integral 1 by 4 pi epsilon 0 q by r square ds. You know, this value 1 by 4 pi epsilon 0 q by r square at every point is constant. So we have to add up only the small areas. Therefore, the equation can be written as 1 by 4 pi epsilon 0 q by r square closed integral ds. Equation becomes 1 by 4 pi epsilon 0 q by r square into 4 pi r square. 4 pi r square is the surface area of the sphere. 4 pi r square in the denominator and 4 pi r square in the numerator can be cancelled. So the equation becomes 1 by epsilon 0 into E. Thus, the Gauss's theorem is proved. According to the theorem, total flux through the closed surface is 1 by epsilon 0 times total charge enclosed by the surface.